All right, building up to a challenge problem that involves, well, here's what the challenge problem looks like. For the value of x for which 2x plus 3 over x minus 3 minus 1 equals 12 over x plus 3 plus 1. I want to solve that. Well, in order to do that, we're going to go all the way back to how do you solve something like this. Now, I'm assuming you've been taught how to solve an equation like this, but I'm probably going to do it a little differently than what you were taught. Okay, so what I'm going to do is I'm going to use a technique that works regardless of how the equation is set up. There's a way that a lot of teachers teach this problem, and I perfectly understand why they teach it that way. It's kind of a shortcut thing that they do, but the reality is what they're doing only works if it's set up specifically this way. However, what I'm going to do works regardless of how it's set up. If you have fractions in an equation and you want to get rid of the fractions, I'm going to show you how to do that so then it becomes more solvable because you don't have the fractions to deal with. What we're going to do is we're going to multiply both sides by the common denominator. Now, because both denominators here, one is 11, one is 5, they share no common factors, the common denominator is simply their product. So we're going to have 5 times 11, we're going to multiply the entire equation by. Now, why do we do that? Well, as we distribute this 5 times 11, when you take this times this first fraction, the 11's cancel, and you're simply left with 5 times 2x minus 7. And then on the other side, when you multiply the 5 times 11 over here, the 5's cancel, and you're left with 11 times x plus 1. Now, you may recognize this as what some teachers would call cross product. This times this equals this times this. There is no such thing as cross product as far as a rule. It's a shortcut, and I really would prefer not to talk about it because if you do it this way, if you do about the way I'm thinking, you're going to see in the next problem it still applies even though we don't have it set up because cross product only works if it's two fractions equal to each other in this way. So now you distribute 10x minus 35 equals 11x plus 1. And now you're going to solve real quickly. You're just going to get everything on one side. So negative 36, because I subtracted 1 from both sides, equals x. And so you figured out that x is negative 36 and you solved it. Now, if you go to one that looks like this, again, the big thing you're dealing with here is you're like, oh man, there's all these fractions. How do I deal with these fractions as far as solving this equation? Well, what we're going to do is just what I showed you to do. We're going to multiply the entire equation by the common denominator. Well, what are my denominators? My denominators are 5 and x plus 1. Again, they share no common factors. So I'm going to multiply both sides by 5 and x plus 1. Now, what happens is I distribute that. Well, as I multiply this times this, the x plus 1 cancel, and I'm left with 5 times 9. Plus, when I multiply this times this, the 5's cancel, and I'm left with 2 times x plus 1. And now that equals, when I multiply this by this, again the x plus 1's cancel, and I'm left with 5 times 12. And now with one step, all my fractions are gone. So now I just have to simplify. That's 45, then 2x plus 2 equals 60. Now I'm going to get everything, get the variable on one side, so the 2x stays by itself. That's 47. So 60 minus 47 is 13. And then x equals 13 halves. Now I'm going to be honest, I made this up, and I thought I made it come out nicer than that. I'm going to double check and make sure I didn't make an arithmetic error. I don't see one, so I think I'm good. That's definitely 45, that's definitely 60. Yep, we're good. Okay, so now we're going to move on to the question that they asked. So this one, again, for what seems like now the third time. What am I going to do? Well, I've got fractions in an equation that I don't want. So I'm going to take that original equation, and I'm going to multiply it by something. I'm going to multiply by the denominators. Well, what are the denominators here? Again, they have no common factor. So my denominators are x minus 3, x plus 3. They don't share anything in common, so there's no other way to do this than to just multiply by that denominator. Now, what happens as I multiply? Well, this gets multiplied by this, and the x minus 3's cancel, and you're left with x plus 3 times 2x plus 3 minus, well, I multiplied that by 1, I just get x minus 3. Anything times 1 is just itself. And that equals, now when I multiply this by this, the x plus 3's cancel. So I'm left with 12 times x minus 3. You'll notice I switched the order on those just because it's convenient. And then lastly, again, we're going to have the same thing because we're multiplying by 1. Now, the fractions are gone. Now I'm left with a big simplification problem. I'm just multiplying out. I'm multiplying this by this. Now you can use the box method, or you can use, the distributed property, or, some teachers call it the rainbow method or whatever. And as you're multiplying this, you're going to get 2x squared plus 9x plus 9 when you do the distributed property and multiply it out. And likewise, when you take this, you're going to get x squared, and then the negative 3x and the positive 3x add up to 0, so we're just left with minus 9 equals 12x minus 36 plus x squared minus 9. Now I have like terms. Well, this negative sign right here, I'm going to distribute over. So it's going to become a positive. That's going to make this a negative, and it's going to change that to a positive. So now I have like terms. So I'm going to combine some like terms. So 2x squared and negative x squared give me x squared. I have plus 9x, and then I have plus 18. And that equals, and again, I've got a few like terms over there as well. So I'm going to get x squared, and I'm going to get 12x minus 45. Now, I'm really kind of pleased at this moment, because when I go to get rid of something, I notice there's an x squared on both sides. So if I subtract x squared from both sides, those just go away. So I'm left with 9x plus 18 equals 12x minus 45. And now I'm in a standard, 5-step equation. So 63 equals 3x. 21 is x. And I'm done.